Hi, Assalamualaikum and good evening. So for this video, I will be talking about titration between weak acid and strong base. So for this titration, it will be a bit different than the titration between strong acid and strong base because there's something that you need to consider for this titration is the formation of buffer solution, which indirectly being produced from the titration. Okay, let's look at the equation first. So we have ethanoic acid as the example of weak acid. Ethanoic acid reacts with sodium hydroxide in a titration to produce sodium ethanoate. This is the salt, and also H2O. Okay, and then I also have written the dissociation of each of the component here. So we have ethanoic acid dissociate into ethanoate ion and H+, sodium hydroxide dissociate completely into sodium ion and also a hydroxide ion. Sodium ethanoate will dissociate into ethanoate ion and sodium ion, and then H2O is H+ and OH-. Oh, this one I written it wrongly. We're supposed to be H2O in front lah, but it's the same actually. Okay, so let's look at the curve, the titration curve. So for the titration curve, what you will notice for this is it is a bit at region A, it is a bit the curve does not increase as we increase proportionally as we increase in the volume of the titrant. This part is where the pH being resists. So this is actually where buffer is being produced. We will talk about that later. So we look at, again, there will be three different regions of how you calculate these three different regions. Same just like the titration between strong acid and strong base. So for this is also, we have also three regions here. Okay, so for part A, you have two types of calculation. One is here right before any titration happen, and then along this line, what you need to consider to calculate. Okay, so we go first to the first point here. Okay, before any titration happen, what exists is only ethanoic acid. This is what exists before any titration. So this is 1 molar, 1 liter. So by using this formula here, this is weak acid. Okay, so weak acid, you need to use this formula here. It's not, Ka is not given, it's not written here, but you can, in the question, it will be given to you. So Ka times C, C is the concentration, it is 1 molar. So you times with Ka, square root it, you will get the concentration of H+. Just plug it in this negative log H+, you will get the pH here at the beginning of the titration. That is for the weak acid. Okay, and then what happened after that along this line here, along this curve here for region A? So at that time, we already add in sodium hydroxide, but the amount of sodium hydroxide added, it's not yet equal, because you need to remember at region B, where equivalent point will exist, it is when complete neutralization happen. The amount of acid and base is equal. But before that, at region A, the acid is still, the amount of acid is still a lot. Sodium hydroxide being added is still little. So we will use this ice table to show you what really happened. Okay, so we have here ethanoic acid, 1 molar and 1 liter. I just use simple number to show you guys. Okay, so for example, the amount of sodium hydroxide being added is 0.1. I write it down here, 0.1 mole. Okay, so what happened in a titration like before is the acid will neutralize the base. So the amount of acid when react with NaOH, what will happen? NaOH will completely neutralize, so it become minus 0.1, and then ethanoic acid will neutralize sodium hydroxide, so this is also minus 0.1. But for the salt, it will increase 0.1. So the changes here is 0.1, 0, and also this one will be 0.9. Okay, so that is the amount of mole after the changes. So what we notice here is the final product will be in the conical flask for the analyte will be both acid and salt. So if you look at here, this is weak acid, this is its conjugate salt. Both of them exist at the end of region A, at the end of the titration. Both the acid and the salt exist together. So the definition of buffer is a mixture of weak acid and its conjugate salt. So at the end of the titration within region A, buffer solution will exist. So to calculate the pH along this curve at region A, you need to use the formula Henderson-Hasselbalch. pKa times log salt. Salt is this one, and acid is this one. But you need to remember, this is mole. You need to divide with the total volume. As we know, this is 1 liter, and then this one is depend on the question, how many moles, how many liter has been added, how many milliliter has been added. So you will have the pH for region A. Along this line here, you need to use this formula. You need to use this method to get the value. Okay, so next we will look at part B. Part B is when the pH drastically change. If you look at here, it will drastically change. And then along this curve, equivalent point can be found. Okay, so because this is the titration between weak acid and strong base, the equivalent point will be pH more than 7. Okay, they will be more than 7, meaning that the pH, the equivalent point will be basic. Why is this? Why is the pH more than 7? So we look at this ice table now. Okay, we start again. So as we know that our acid is 1 mole, at region B where the equivalent point exists, complete neutralization will happen. So if complete neutralization will happen, how much mole of sodium hydroxide has been added into? It will be 1 mole. Okay, so if it is 1 mole, meaning that the changes, it will neutralize 1.0. This also will be neutralized 1.0. And then this will be produced 1.0. So at the end, the amount is 0, 0, and this is 1.0. So the final product or the final ion exists in the conical flask at the end of titration within region B will be salt and water. Salt, this salt is basic salt. How do I know this is basic salt? We look at here. This salt here, when dissociate, you will get CH3COO minus, the ethanoate ion, and sodium hydroxide, sodium ion. So when we use the ethanoate ion in water, what will happen? It will produce back the weak acid and the OH minus. OH minus indicates that this salt is a base. So to calculate the pH, you need to use this formula. This is base, weak base. This is weak acid, its conjugate will be weak base. So to calculate weak base, you need to use OH minus equals to Kb times C. The problem is, the Kb is not given to you. This Kb here. C is concentration. You can use this one because this is the concentration of the salt being produced. But Kb is not given to you. Sometimes Kb is not given to you. So how do you get the Kb value? So in the question, Ka will be given. So if Ka is given to you, you can use this formula here. Kw equals to Ka times Kb. Okay? So if Ka is given to you, Kw you already know the value. So you can get the Kb of the salt, of the conjugate salt. So after you get Kb times with the concentration here, this concentration here, you will get OH minus. So you can find the pH through that. So that is why the equivalent point is more than 7. It will be basic. That is for region B. Sorry, that's my shadow over there. Okay, so let's look at part C. So part C, this is the ice table for part C. Okay, again, for part C, same with the titration between strong acid, strong base. Part C is when the base, NaOH, is more than the acid. The amount of OH minus ion is more than the acid. So what happened here? For example, this is 1 mole. So this is 1.5 mole. So if that is 1.5 mole, because this is only 1 mole, you can only minus 1 mole. Minus 1 mole. And then it will produce 1 mole also plus. So when you minus all of this, you will get 0. This is 0.5 and this is 1 mole. Okay. So now you have 2 base. This from part B, we know that this salt is a base, weak base, and then NaOH is a stronger base. So to calculate the pH at region C, you directly use this mole. Use this mole. How to get this value? You just directly negative log the value of OH minus concentration, which is this one. So if you negative log that value, you get POH, and then you can get pH from there. Okay, so that is how you calculate the pH for the titration between weak acid and strong base. And you can also apply this with the titration between weak base and strong acid. It's the same actually. Okay, you just need to understand which one is the titrant, which one is the analyte. Okay, that's all for this video. Thank you.